m raised to power 2 minus n raised to power 2 all over 2mn. Then we should find sec theta. Now, of course, using the knowledge about trigonometry, we have SOHCAHTOA. Now, tan theta is equals to 2, which is equals to opposite over adjacent, which is equals to m raised to power 2 minus n raised to power 2 all over 2mn. Then doing the right angle triangle, we have this type. We have these are opposite facing the theta angle, then which is what m² minus n². These are hypotenuse and these are adjacent. Our adjacent is 2mn. Hypotenuse what is x? We don't know. Let's just say x, right? X. We don't know. It is unknown for now. Then using the Pythagoras formula, which says that opposite square plus adjacent square equals to hypotenuse square. Now, what is opposite square? What is the value for opposite rather? M raised to power 2 minus n raised to power 2 all square, this square, plus adjacent 2mn all square, this square on top of the adjacent. The hypotenuse, we don't know that. Then we represented it with x this square. Now this one means m raised to power 2 minus n raised to power 2 in two places, plus this one means 2 raised to power m times 2 raised to power m equals to x squared. Now m² times m², law of indices, we are going to bring out multiplication law that states that indices a raised to power x times a raised to power b will be equals to ax plus b. We're going to add the powers together. The same thing here. m² times m² will give us m raised to power 4. Then that's it. m² times minus n will give us minus m² n² minus m². Minus n² times m² will give us minus n² m², and then minus n² times minus n² will give us plus n raised to power 4, plus 2 times 2 will give us 4, m times m will give us m², n times n will give us what? n² equals to x². Then we can now rearrange as m raised to power 4 minus m² n² minus m² n² plus n raised to power 4 plus 4m² n² equals to x². Then we can now continue by m² n² they have the same variable here. In other words, we can add or subtract them because they are of the same like. So m raised to power 4 n minus m² n² minus m² n² will give us minus 2m² n² plus n raised to power 4 plus 4m² n² equals to x². Then now we have the same like, which is minus 2m² n² and 4 and plus 4m² n². Now we can then bring them together. Now minus 2m² n² plus 4m² n² will give us plus 2m² n² plus n raised to power 4 equals to x². Then we can now factorize out. Right? We can factorize out, which should give us, another quadratic equation plus m² n² plus m² n² plus n raised to power 4 equals to x². Now what is going between m raised to power 4 plus m² n²? That is m raised to power 2. It's common. What is common between m² n² plus 4 plus n raised to power 4? m² is common. Then bring them together to now be what? m² plus n² m² plus n² equals to x². Now they both occur twice, right? So we can say m² plus n² square, because they are in two places, equals to what? X square. Then we can now what? Can now square root both sides, because we're looking for only x. Square root both sides. So x now equals to square root. Sorry. Yeah. Or square. So that's value for x. So our hypotenuse is m square plus what? N square. Then we are what? We are gonna find sec theta. Sec theta equals to 1 over cos theta. And what is cos theta? That is 1 over cos theta equals to adjacent, which is k, which is 1 over adjacent over hypotenuse. That is 1 divided by adjacent over hypotenuse, which is equals to 1 times the reciprocal of adjacent over hypotenuse is hypotenuse over what? Adjacent. That is 1 times, what is the hypotenuse now? That is m square plus n square all over, what is adjacent now? 2mn over 1. 1 times m square plus n square will give us m square plus n square over 1 times 2mn will give us 2mn. So that's the final answer for sec theta in the question.